Modigliani Miller theory, weighted average cost of capital, and asset valuation.
In finance, assets are often valued by the sum of cash flows discounted by Wacc, weighted average cost of capital. However, asset valued with Wacc method often differs from the other valuation method of asset as the sum of equity and debt. This is often attributed to simplified assumptions about cash flows. Could there be problems with the theory itself? We will look into the theoretical foundation of corporate finance.
The theoretical foundation of corporate finance is very simple. It mainly consists of only a single paper, Modigliani and Miller's 1958 paper on the irrelevance of financial structure. In that paper, Modigliani and Miller derived formula of weighted average cost of capital. Wacc is often used in corporate finance to value investment projects. It is a very important discount rate. The cost of capital is an important concept in finance. MM 1958 paper is the most important paper in corporate finance. Both Modigliani and Miller got Nobel Prizes. There are three major propositions in this paper. We will go over them separately. Proposition 1. V is equal to x plus d is equal to x over rho. Here, V is the value of the whole investment project. S is the equity or stock value. D is the debt value. X is the expected cash flow per unit time. Rho is the discount rate. The sum of equity and debt is equal to the value of the project. The average return per unit time is assumed to be constant to perpetuity. The value of the project is equal to average return per unit time divided by the discount rate. Proposition 2. The relation among equity discount rate of the levered firm, the debt rate, and discount rate of the unlevered firm is Rs is equal to rho plus rho minus R times D over S. Here, rho is the discount rate of the unlevered firm. Rs is the equity discount rate, and R is the debt rate. Rearrange the above equation, we get rho is equal to D over D plus S times R plus S over D plus S times Rs. This is the formula of Wacc, weighted average cost of capital. So you can see here, the first part of the formula is the weight is D over plus S. So this is the weight of the debt. The second part, RS is the discount rate for the equity. Its weight is S over D plus S. So it's the weight of the stock. Proposition 3. An investment project should only be undertaken if and only if the expected rate of return of this project is as large as or larger than the cost of capital. So this is the theory. But how about empirical results about theory? There are different valuation models for assets. It is well known that valuation from Modigliani and Miller theory may differ from other models. What is our opinion about the differences in valuation? Here is an representative opinion from an investment textbook by Boddy and others. In principle, the free cash flow approach is fully consistent with the dividend discount model and should provide the same estimate of intrinsic value. This was demonstrated in two famous papers by Modigliani and Miller. However, in practice, you will find that values from these models may differ, sometimes substantially. This is due to the fact that in practice, analysts are always forced to make simplified assumptions. We have some questions about paper. All the results in Modigliani-Miller paper, including the formula of Wacc, are obtained when the average payoff from the project is assumed to be constant to perpetuity. If this assumption is not true, will the results stay? In another paper by Miller and Modigliani, they themselves had warned against drawing broad conclusions from special cases. This is merely one of a number of peculiarities of this special case on which, unfortunately, many writers have based their entire analysis. The reason for the preoccupation with this special case is far from clear to us. Certainly, no one would suggest that it is only an empirically relevant case. Even if the case were in fact the most common, the theorist would be under an obligation to consider alternative assumptions. We suspect that, in the last analysis, the popularity of internal financing model would be found to reflect little more than its ease of manipulation combined with the failure to push the analysis far enough to disclose how special and how treacherous it really is. Our obligation. Certainly no one would suggest that constant cash flow to perpetuity in Modigliani-Miller paper is the only empirical relevant case. Even if the case were in fact the most common, the theorist would be under an obligation to consider alternative assumptions. Some further hint, in bond pricing, there is an adjustment called convexity. This suggests that discount rate is a nonlinear factor, but the WACC is a linear combination of two discount rates. Could there be problem for WACC for general cash flows?
Let's do some derivation. We assume an investment project is financed with debt and equity. The coupon payment from debt changes at the rate of K per year. The dividend payment from the equity is expected to change at the rate of G per year. The asset value, V, is the sum of debt and equity. V is equal to D plus S. The value of an asset is also defined as total cash flows discounted by WACC. Let V prime represent the asset value calculated from this definition. We can derive that V prime minus V is equal to A times G minus K. Here, A is a positive coefficient. When K is equal to G, investment valuation from cash flows discounted by WACC gives correct answer as the sum of debt and equity values. When K is equal to G, debt-equity ratio is constant over time. This means that M&M theory is valid when debt-equity ratio is constant over time.
In all other cases, cash flows discounted by WACC gives incorrect answer. When G is greater than K, investment valuation from cash flows discounted by WACC overvalue investment projects. When G is less than K, investment valuation from cash flows discounted by WACC undervalue investment projects. Modigliani and Miller theory is not valid for more general cash flows or more general capital structures. Modigliani and Miller theory often overvalues growth firms and undervalue value firms. Our derivation shows that the problem is caused by simplified assumptions in the theory, not by simplified assumptions in practice. For systematic discussion, please check the following paper on the theoretical foundation of corporate finance. Numerical examples. We can also experiment with some numerical examples. This will help us gain more intuition. Example 1. A company will distribute coupon amount to $3 million to bondholders and dividend amount to $3 million to equity holders next year. The market value of the perpetual bond is 100 million, and the market value of the equity is $100 million. Assume the growth rate of dividend is 4% per year. What is the cost of equity? What is the cost of debt? What is WACC? What is asset value calculated from discounting by Wacc. What is the asset value as the sum of debt and equity? Are two results the same? Solution. The cost bond is 3/100, which is the coupon payment over the bond value. It is equal to 3%. The dividend yield of equity is 3/100, which is the amount dividend over equity value. This is 3%. The cost of equity is dividend yield plus growth rate, which is 3% plus 4% equal to 7%. Wacc is the weighted average of cost of debt and cost of equity, which turn out to be 5%. Now we calculate asset value as cash flows discounted by Wacc. Cash flow is 3 plus 3, 1 plus 4%, the power of I minus 1. This is essentially the sum of coupon payment plus dividend payment of various years and discounted by Wacc accordingly, which is 5%. And we can do the auto calculation and find out the result is $360 million. The sum of debt and equity is 100 million plus 100 million, which is $200 million. So the asset value calculated from Wacc is 1.8 times the value of debt plus equity. Wacc overvalue asset for growth firms. Now let's do example 2. A company will distribute coupon amount to $3 million to bondholders and dividend amount to $4 million to equity holders next year. The market value of the perpetual bond is $100 million, and the market value for the equity is $50 million. Assume the growth rate dividend is negative 2% per year. What is the cost of equity? What is the cost of debt? What is Wacc? What is asset value calculated from discounting by Wacc? What is the asset value as the sum of debt and equity? Are two results the same? Solution. The cost of bond is 3 divided by 100, which is 3%. The dividend yield of equity is 4 divided by 50, which is 8%. The cost of equity is dividend yield plus growth rate, which is 8% minus 2% equal to 6%. Wacc is the weighted average of these two costs, the bond cost and equity cost. It turned out to be 4%. Now we calculate asset value as cash flows discounted by Wacc. So it's the sum of from 1 to infinity. The cash flows are 3 plus 4 times 1 minus 2% over power of I minus 1 discounted by the Wacc. And the result is $141.7 million. The sum of debt and equity is 100 plus 50 is equal to 150 million. This is higher than 141.7 million calculated as cash flows discounted by Wacc. This means Wacc method undervalues assets for declining firms. Example 3. A company will distribute coupon amounts to $3 million to bondholders and dividend amount to $3 million to equity holders next year. The perpetual bond has a peculiar arrangement. Its coupon rate increases 2% every year. The market value of the perpetual bond is 100 million, and the market value of the equity is $50 million. Assume the growth rate of dividend is 2% per year. What is the cost of equity? What is the cost of debt? What is WACC? What is asset value calculated from discounting by WACC? What is the asset value? A sum of debt and equity. Are they the same? Solution. Suppose the cost of bond is R. 3 divided R minus 2% is equal to 100. We solve the equation to get R equal to 5%. The dividend yield of equity is 3 over 50, which is equal to 6%. The cost of equities, dividend yield plus growth rate. This is equal to 6% plus 2%, equal to 8%. WACC is the weighted average, the cost of bond and the cost of equity. It turns out to be 6%. We will calculate asset value according to discounting by WACC. So it's cash flows discounted by WACC. It turns out to be 150 million. The sum of debt and equity is 100 plus 50 equal to 150. So the asset value calculated from WACC is the same as the sum of debt and equity. So when the growth rates of coupon payments and dividend payments are the same, WACC gives correct asset value. Example 4. A company will distribute coupon amounts to 3 million to bondholders and dividend amount to 3 million to equity holders next year. The principal of the bond is 100 million. It matures in 10 years. The market value of the bond is 100 million, and the market value of the equity is 60 million. Assume the growth rate of dividend is 0% per year. What is the cost of equity? What is the cost of debt? What is WACC? What is asset value calculated from discounting by WACC? What is the asset value as the sum of debt and equity? Are these two values the same? Solution. The cost of bond is
3 over 100 equal to 3%. The dividend yield of equity is 3 over 60 equal to 5%. The cost of equity is dividend yield plus growth rate equal to 5% plus 0% equal to 5%. Wacc is the weighted average of the cost of bond and cost of equity, which is equal to 3.75%. Asset value, according to discounting by Wacc. Asset value, we have two parts. First part is the bond cash flow. The second part is the equity cash flow. They are all discounted by the Wacc. For bond value, there are two parts. One is the coupon part, one is the principal part. The coupon part, there are 10 terms. We add them together, and the principal part is one term. That's principal discounted by Wacc compound 10 times. And the answer is 173.84 million. The sum of debt of equity is 100 plus 60 is 160. So the asset value calculated from Wacc is larger than the sum of debt and equity. You see here, there's no growth for equity, and the bond coupon payment is constant. Why they're different? The problem here is that debt is mature in 10 years. So we need to assume that will be roll over indefinitely to perpetuity. Now we calculate asset value according to Wacc, but this time the debt will roll over to infinity. So when we calculate this asset value discounted by Wacc, we get 160. This gives the correct answer. Assume the coupon payment from the debt is constant. When G, the growth rate of the dividend, is positive, Wacc will overvalue the asset. When G is negative, Wacc method will undervalue the asset. Only when G is 0, Wacc will provide correct value of the asset. This is the case in M and M picture. More generally, when the growth rate of dividend is higher than the growth rate of coupon, Wacc method will overvalue the asset. When the growth rate of dividend is lower than the growth rate of coupon, Wacc method will undervalue the asset. Only when the growth rate of dividend is equal to the growth rate of coupon, Wacc method will give correct value in asset estimation. We sometimes choose different Wacc for different years to obtain correct asset value. But if Wacc changes every year, some commonly used concepts in corporate finance, such as the cost of capital and expected rate of return for projects, become difficult to apply. Furthermore, it will be difficult or impossible to determine the values WACC of each year from market data. In practice, WACC is sometimes chosen so cash flows discounted by this number will be equal to the asset value. In the first example, the correct discount rate would be 6%. It can be obtained by 3 discounted by 6% plus 3 discounted by 6% minus 4%, which add up to 200. But this rate is not obtained as a weighted average of debt and equity discount rate. It is not really WACC. On the concept of cost of capital, if WACC does not provide accurate discount rate for measuring investment value in general, should we still use Proposition 3 in M&M 1958 paper as the criterion to make investment decision? Does the concept cost of capital give more smoke than light? When we use WACC, are we adding oranges and apples together? Should we keep using the concept cost of capital? Return to equity valuation as a criterion of investment. Instead, investment projects can be valued by residual claims for equity owners, discounted by expected returns for equity. This is more consistent with the statement that investment should maximize equity values. Maximize asset value and maximize equity value are not always consistent with each other. Possible presentation topic: find a specific company, calculate value of assets with two different methods. The first as the sum of debt and equity, the second as the sum of cash flows discounted by WACC. Are they the same? If not the same, can you find investment opportunities?